at Similar Polygons, Unit 5, Day 2. Similar polygons, we did congruent shapes, right? Congruent shapes are exactly the same size, the angles are the same, the sides are the same. We're going to look at similar polygons, or just shapes that have straight edges. So no circles or cones or anything weird like that. Just straight edges, and then they're flat. Polygons are not three-dimensional, they're two-dimensional. Okay? The symbol for similar is this little squiggle, like the congruent, but without the equals. Okay, because these have the same shape, but they're not necessarily the same size. So their sides are not necessarily going to be equal, but they will have the same shape. Okay, so here's what we need to know about two polygons that are similar. Two polygons will only be similar if and only if their corresponding angles are congruent, just like in congruent figures, and their corresponding sides are proportional. So that's why we spent a whole day yesterday on ratios and proportions, is because today we're going to be looking at setting up proportions and needing to be able to solve them. Okay? So remember, proportions means equal ratios, and ratios is just fractions. So proportions are equal fractions. Okay? All right, so here's my example. It says, is quadrilateral ABCD similar to quadrilateral JKLM? Okay, so if they are similar, then all their angles will be congruent. And remember, it's all there. If I look up here, let me go back. It's their corresponding angles that are congruent, and it's the corresponding sides that are congruent. And we're used to reading similarity statements, so we know that this order here, A, B, C, D, is important to this order here, J, K, L, M. That tells me what things are supposed to be corresponding, right? The order is important. So I know that this first letter, angle A, should be, actually, will somebody grab the door, please? Thank you. This first letter, angle A, I forgot my A, should be corresponding to the first letter over here, angle J. And if these two figures are similar, then these angles have to be congruent. So when I look at A, I see this right angle. And when I look at J, I see this right angle. So are they congruent? Yes. Okay. So then after A, I go to B. Angle B should match up with what? Angle K. So B has a single arc on it, and K has a single arc on it. So yes, those are congruent. Angle C should match up with what? L. Angle C has two arcs on it. Angle L also has two arcs on it. So they are congruent. And last but not least, angle D should match up with angle M. And D has three arcs, M has three arcs, so yes, those are congruent. So my first thing to have similar figures is that all my angles, my corresponding angles, are congruent. Yes, all four corresponding angles are congruent. So that's so far so good. The next thing is that the corresponding sides are proportional. That means I have to take my sides and I have to use them to make ratios. Okay, so when I look at this side AB, I'm going to make it a ratio with its corresponding side. What's its corresponding side to AB? JK. Just kidding. Okay. And then I'm going to look at my next two letters. My next two letters are BC. What would BC correspond to? KL. And then my last two letters, CD, should correspond to LM. That's only 3 out of 4 sides. To find your fourth sides, look at the outside letters. AD is going to correspond to JM. If all of these are equal, then we say yes, they're proportional because proportions are equal fractions, right? So if those are all equals, then we can say yes, the sides are proportional. So I'm going to start with AB. From A to B, that's 8. From J to K is 14. Does that equal the next fraction? BC is 8. KL is 14. So yes, those definitely equal each other. I can put in equals there confidently. And then the next one, CD is 8. And LM is 14. Well, yes, those definitely equal each other. And then the last one, AD, all of a sudden I have a different number, 12. And JM, I have a different number, 21. So I need to know, are these fractions equal? Are the 8/14 and the 12/21, can I put in equals here? So what you want to do then is you want to reduce those fractions, because we always reduce our fractions. So to reduce my fractions, I'm going to do 8 divided by 14, and my calculator will do it for me. 8/14 is 4/7. So this first one is 4/7. This one is 4/7. This one is 4/7. They're all equal. Let's check this last one. 12/21, enter, is also 4/7. So even though it's different numbers, they reduce to the same thing. We say yes, they are proportional. Yes, they are proportional. Okay, so my angles are all the same. My sides are all proportional. So when it says, is quadrilateral ABCD similar to triangle JKLM, my answer is yes. Okay. Here's a vocabulary word that we are introducing today, scale factor. Our scale factor is the ratio of the lengths of the corresponding sides. Remember, ratio is just a fancy word for what? Fraction. So we're looking for a fraction of the lengths of corresponding sides. What corresponds to AB? JK. So we're going to make a fraction out of those corresponding sides. That's going to give us our scale factor. Okay, so I'm going to give you about a minute or so for you to find these two scale factors using the problem that we just did. Comparing two side lengths that are corresponding. I've got ABCD, quadrilateral ABCD to quadrilateral JKLM. This one comes first, so that's going to be my numerator. This one comes second, so that's going to be my denominator.
Did you write it out?
You can. We did it 4 times.
I don't know what it was asking.
Write a fraction comparing two corresponding sides. Write a ratio comparing two corresponding sides. About half a minute. We already did it 4 times. Anybody have guesses? What's the first scale factor? ABCD to JKLM.
AB.
It's going to be a ratio, so it's going to be a number over a number. 8/14 ratios are always reduced. 4/7. Or you can write it as 4:7. Right? I said we did it 4 times. We made 4 ratios, right? And those ratios, the scale factor is the ratio of corresponding sides. How do we make these? These are corresponding sides, right? We were looking at corresponding sides that were proportional. these are corresponding sides as a ratio. These are corresponding sides as a ratio. Corresponding sides as a ratio, corresponding sides as a ratio. We always reduce our ratios, so that's 4 over 7. Notice my ABCDs were all in the top, my JKLMs were all in the bottom, so we do want 4 over 7 if ABCD is on the top and JKLM is on the bottom. What is it going to look like when I flip this around, JKLM to ABCD? 7 over 4. All you do is flip it over. All you have to do is flip it over. All right, example 2. In the diagram, triangle BCD is similar to triangle RST. What is the scale factor of BCD to RST? Use the scale factor to find X. So remember, your scale factor you find by making ratios of corresponding parts. What part is going to correspond to BC? RS. What part is going to correspond to CD? ST.
Oh.
What part is going to correspond to BD? RT. These will all reduce, since they told me these are similar, these will reduce to the scale factor. How long is it from B to C? 12. How far is it from R to S? 24. How far is it from C to D? 13. How far is it from S to T? We don't know. How far is it from B to D? 5. How far is it from R to T? 10. These all reduce to the scale factor. Now, I can't reduce this one, but I know that all 3 of these are going to reduce to the same thing. What are they all going to reduce to? What's my scale factor? Right? 12 over 24 is 1/2. 5 over 10 is 1/2. So my scale factor, even though I don't know that middle fraction, I can still find my scale factor is 1/2. Even if I only know one of these whole things, as long as I know one whole fraction values, I can find my scale factor. So that's the first thing it said, is what is the scale factor of these 2 triangles? Then it says use the scale factor to find X. Well, I can do that. If I want to find this X, I know what this fraction is supposed to reduce to. What is it supposed to reduce to? It's supposed to reduce to? No, it's supposed to reduce to the scale factor, which is 1/2. And then I cross multiply to solve, and then you can tell me the answer you've been screaming out. How big is X? 26. I love when you're supposed to answer 1/2, you say 26. And then when the answer is 26, you say 1/2. Okay, so my scale factor is 1/2, which helps me find X, that is 26. Okay. All right, hexagon ABCDEF is similar to hexagon GHIJKL. Find the following. What is the scale factor? Okay, so remember, our scale factor is found using corresponding sides, right? So when I look at this picture, if I look at my corresponding sides, what side is going to correspond to this side right here that's 12? Over here. IJ? Because AB and IJ are corresponding, yes? Are those in the same spots? No, those are not going to match. What is AB actually going to match up with? AB is going to match up with GH. Okay, well, AB is 12. GH is what? 9. Can I reduce that? What's 12 over 9? 4 over 3. I don't have to set up all those fractions. As long as I have one that works, that's all I need to find the scale factor. This is my scale factor. 4 to 3. is my scale factor. Okay? So then when it says to find LK, when I look over here, AB was in my numerator. So that means everything from this figure is always going to go on top of a fraction. And anything from this figure is always going to go on the bottom. Because we did A, B, C, D, E, F to G, H, I, J, K, L. So A, B, C, D goes on top, G, H, I, J, K, L goes on the bottom. Okay? So when I'm looking to find LK, LK is going to go on the top or the bottom of a fraction? It's going to go on the bottom of a fraction because it's got my down arrow there. So I'm going to put it underneath the fraction bar. What is LK going to match up with? FE or EF, right? You can say it either way. It's the same thing, but FE. Okay. So what is this fraction going to reduce to? They all reduce to the same scale factor, 4 to 3. FE is how much? 16. LK, we don't know. That's what we're trying to find. That's going to equal 4/3. We're going to cross multiply. 4 times LK is going to equal 16 times 3. What's 16 times 3? It's what? 48. I know. Divide both sides by 4. How big is LK? How much? Yeah, right. Okay, I skipped a step because I thought we were in advanced. Let me not skip that step. 4 times LK divide by 4. Division property of equality. How far is it from L to K? 12. Okay? All right, C says find the measure of angle L. Does angle L go in the top or the bottom? Bottom. That was a trick question. Anybody know why that's a trick question? Angles are what? They're congruent. They're not proportional. I don't have to make a fraction. There's no top or bottom for angles. Angles in one figure are exactly the same as angles in the other, right? When I look at this example here, A was 90, its corresponding one was 90. B has this single arc, K has the same arc. C has an equal arc to L, D has an equal arc to M. The corresponding angles are just plain equal to each other. They're way easier than sometimes you want them to be. Like, super simple. All I have to do is figure out what does L go with. So L goes with what? L goes with F. So that means L is the same size as F. How big is F? Yeah. So that means the measure of angle L is equal to 95 degrees. So it's only sides that you have to set up proportions for. It's not angles. Angles are equal. It's only sides that you have to set up proportions for. The angles are equal. Okay? All right, so work on D and E. I'll give you about 2.5 minutes for D and E. So D, you're finding a side. How far is it from C to D? So you will have to use a proportion, but E, you're finding an angle. So those are just going to be equal. About 1 more minute. If I start with the second one, E, because that's the easier one, angle J, what does angle J correspond to? Angle, which one? D. So if D is 130, then that means angle J is 130. For C or D, did you put CD in the top or the bottom? Top. It's in the first, it's in this one here, right? So this A, B, C, D, E, F always goes on top. So CD should be on the top of IJ. So CD over 12 equals, it's going to reduce to that same 4/3. And then when I cross multiply, 3 times CD equals 48 inches. Divide both sides by that 3. And CD is going to equal 16 inches. Huh? Because 48 divided by 3 is 16. 48. Yes. So, CD over IJ. CD over 12. This is going to reduce to this scale factor 4/3. Then we cross multiply. C times 3 is 3 times CD. 4 times 12 is 48. We divide both sides by 3 and we get C to D equals 16. These are not congruent. They won't have the same size. These are not congruent. They will not have the same size. Okay? All right, the last thing we're going to talk about is perimeters of similar polygons. So remember, for perimeters, you add up all the sides, right? Add up all the sides, and that's how you find the perimeter. If two polygons are similar, then their perimeters are proportional to the scale factor between them. Okay? So in a nutshell, that means that perimeter ratios will equal the same scale factor. Oh. Hold on. Oh no. All right, the same scale factor. Excuse you, please. Thank you. All right, so here's an example. If quadrilateral KLMN is similar to quadrilateral PQRS, so I know they're similar, then find the perimeter of quadrilateral PQRS. So the first thing I need to do is figure out, well, I do have for sure two similar figures. I need to figure out their scale factor. I need to decide at the beginning of this problem. It's not asking me for the scale factor, so I can just do whatever I want. I need to decide which figure I want to be my numerator and which figure I want to be my denominator. Which figure, the one on the left, the JKL or the KLMN, or the one on the right, the PQRS, do we want to be our numerator on top? The one on the left? So just so that I make sure I don't forget that, I'm going to put an up arrow in that one. And I'm going to put a down arrow in this one. Oh, poops. Let's see if it's going to work. Okay, so then the only side I know from this one is PQ. And I know I've got a down arrow there, so that's going to go in the bottom. what is going to correspond to PQ? KL. So that's going to be KL. This is going to reduce to my scale factor. Okay, KL is 8. PQ is 20. That's my scale factor. We always reduce our scale factor. What does that reduce to, 8 over 20? 2/5. Okay, so if I want to find the perimeter quadrilateral PQRS, I could say, okay, well, that means this 12 over x equals 2/5, cross multiply solve. 12 over x equals 2/5, cross multiply and solve. 6 over x equals 2/5, cross multiply and solve. And then add all of those together after I've cross multiplied 3 times. That's a lot of work. I know that my perimeters will equal the same scale factor, the ratio of my perimeters. So that means if I take this first one that I have my up arrow in, if I take the perimeter of that one, KLMN, and I make a ratio with the other perimeter of the down arrow, PQRS, they're going to reduce to that exact same scale factor, 2 to 5. Okay? Well, I know all 4 sides of this one. I can add 12 plus 12 is 24, plus 6 is 30, plus 8 is 38. So the perimeter of this one is 38. The perimeter of this one, that's what I'm trying to find. So the perimeter of KLMN, this one, is 38. Over the perimeter of PQRS, that's the one I'm trying to find. I'm going to call it X. It's going to reduce to the same scale factor, 2 to 5. Cross multiply and solve. 2 times X and 38 times 5. 38 times 5. 190. Divide both sides by 2, division property of equality. How big is X? How much? 95. So 95 is the perimeter of PQRS. And I didn't have to find all of the sides to be able to do that. I could have if I wanted to, but that would have been a lot more work. All right. Example 5, a large cement rectangle is being poured for a courtyard in place of a smaller one. They're rectangular, so you're going to have a big rectangle and a small rectangle. The big rectangle is your new one because a large one is being poured in place of a smaller one. The smaller one is the old one. The new courtyard will be 20 feet wide and 25 feet long. The old courtyard was similar, but only 16 feet wide. We don't know how long. We could figure it out, but we don't know that we need to. Find the scale factor of the new courtyard to the old courtyard. Okay, so if I'm doing new courtyard to old courtyard, my new is going to go in the numerator because they're telling me what order I have to do it in. My old is going to go in the denominator. Okay, I would recommend sketching a picture so that you can do it. Okay, I would recommend sketching a picture. I'm going to give you about 2 minutes because you just have to write a ratio and reduce it. Sketch a picture, write a ratio of corresponding sides, and reduce it. About 30 seconds. Did anybody find the scale factor of the new courtyard to the old courtyard? What is it? 5/4? Let's see if that's what I got. That is what I got. So I knew my width on both of them, right? I knew my width on this one was 20 and my width on this one was 16. I'm doing new over old. So my new width over my old width, 20 feet over 16 feet, reduces to 5/4. I can write it as 5/4 or 5/4, or as a sentence 5/4. Okay? Then part B says find the perimeters of the new and old courtyard. I already found the perimeter of the new one because I have all four sides. So it's 20 and 25 and 20 and 25. So that's easy enough to do. The perimeter of the new one is going to be 20 plus 25 plus 20 plus 25, which is 90 feet. Now I need to find the perimeter of the old one. Okay, my perimeters will reduce to the same scale factor. So new over old, I don't know the old, but it's going to reduce to this same scale factor, 5/4. So that's going to be 5 times x equals 360. What do I do next? I already did that. I already cross multiplied. 5x equals 360. It's like one of the first things we learned in Algebra 1. Well, how did you do was my question. Divide. Divide by 5 on both sides. And x equals 72. And my units are going to be the same, so it's going to be 72 feet. So my new perimeter is 50 feet of the new bigger rectangle courtyard, and the old one was only 72 feet of my old smaller rectangular courtyard. Okay, don't forget you have your in Schoology, you have your independent practices. Make sure you're putting them in to Schoology.